Hey guys, welcome to ConsoleKit workshop. Before we start, I would like to give a brief intro about Brahma and what we do at Brahma. So, Brahma builds infrastructure for agents and users to execute on-chain interactions in an autonomous manner. And we built the user-facing layer as well, user-facing account layer, which spans across 7 chains and operates in an autonomous manner. We have scaled the account layer operations to manage across 300 million in TVL and 1 billion plus in volume. And we built the console kit for the developers to build similar experiences for their agents as well. I have my team member Rahul with me. He leads our backend, and he will be walking you through the workshop. Thank you.
Thank you for the introduction, Baki. So, welcome all to the Console Kit workshop. To start with, Console Kit is our SDK which enables developers to build agents and more than just build agents, actually bring them on chain. So, to start with, what agents are anything who can do stuff autonomously on basically user accounts. Now, at Brahma, we have already, as Bapi mentioned, we have already built this user-facing layer, which was used via our console UI by the users. Now, the same user interfacing layer is available to all the agents via this ConsoleKit SDK. So your agent can take trades to transaction on behalf of the user at any time of the day without them having to intervene. And all of this is like very gated and streamlined in a way that developer has to focus very less to focus on like the infrastructure layer, the tooling layer, and abstract all of that and bundle it in console SDK. So you can build something like a smart DCA trigger or a smart agent, which basically analyzes the market conditions or does some kind of complex algorithmic stuff and then takes trade on behalf of the user, everything without the user having to interact with the agent at all. So before starting with a demo of ConsoleKit itself, I would like to introduce a bunch of actors which are involved in the system and how the system works overall. So, as mentioned earlier, the user who is delegating or giving permission to an agent or as we call an executor creates a Brahma account, which is basically a multisig. And inside that multisig, we create another multisig which is called a sub account. The sub account has very limited permissions and has a very limited scope in terms of in terms of what the executor can perform. So the user dictates the permissions like, oh, the executor can only transfer 1 ETH every 1 hour, or the executor can only transfer 1 ETH to the Uniswap router to only stop. The executor cannot pull the funds out of the sub account or do anything malicious with it. Now, all of this together makes a very safe environment for the executor or basically the agent to do anything as long as it complies with the user's permission. So this is a safer way of giving permissions or like giving access to AI agents without giving them full access to your private keys or the way it currently works. Now, once we have like the base actors covered in the system, let's go over and see a quick demo of how this whole system actually works. So we have this Scaffold Agent SDK or Scaffold Agent repo, which is basically a simple starter repo. You can clone it up and you can go inside and view around what scripts are present, and I'll just walk you over it. So to get started, let's just go over the env which we have to set up before doing anything. We basically need the console API key and the console base URL, which we have already shared on our Notion, and I'll drop a link in the chat as well. And apart from that, the obvious JSON RPC URL, and we are just using private keys here, which one of which would be our executor or basically the AI agent, and the another one would be our user who is basically interacting and delegating permissions to the agent. So let's go over and register our agent or basically the executor who is asking permissions on the user's sub account. To start a registration, we need to first define a couple of params. This starts with your client ID. Basically, this is just a unique identifier for yourself. You have your executor address, and this address is the one who will be like signing the call data and sending it over to the console network, and then console network will finally validate it, check the policy stuff, and then ultimately relay it on chain. And then we have two couple of interesting fields. One of them is hop addresses and input token. So basically, this hop address field dictates where and to what addresses your agent can actually move funds to. And these fields are visible to the user as well. So while the user does the subscription, he can go and check and validate these addresses, that these addresses are the ones which the user understands and not some malicious addresses. And we have input tokens, and basically these tokens are what we're asking the user's permission on. So basically, this is base USDC, and you're saying, "Oh, I'll run automation on this base USDC address, and apart from this token, I cannot move any other token in the user's given sub account." And you have a flag called limit per execution. So when the user defines those concrete limits, which are like base only 10 USDC can be moved, they apply to per execution, and this can be modified to make it a duration based policy as well, saying 10 base USDC can be moved every 1 hour or every 2 hours, and so now. And this timestamp is basically when you as an executor are registering this metadata on our console backend. And now the script simply just goes and goes through the SDK calls, registers it, signs it, and it also registers on kernel. So kernel is basically the automation service which keeps calling your agent or your executor every given specified interval by the user, and will just ask you to build the call data and send it over. Now, so you don't have to manage anything on like managing user subscriptions or who has given you access, what accesses you have. You just have to take care of building the final intent or the call data, and the rest is handled by the SDK itself. So this is what this register executor script does, and it basically just creates a subscription for us. Now let me just go ahead and register my executor. So I'll just bring in a new executor key. Let me just create it. I'll just add my key to the env, and I'll then run the script. So I've added my key to the env, and you'll populate the sample env for reference. And let's just go and run the simple make command to register my executor. So I'll just do make run register executor. I press enter. Starts registering the executor. Will build the metadata, go over to kernel and register it. So once I'm registered, as you can see, the policies are already taken. Executor is registered with a unique ID, and now from here onwards, we'll always use this unique ID to refer our executor in further operation. So while registering on kernel, I have also defined that this is a interval-based automation or agent, which at every 120 seconds interval will do some kind of execution or at the interval defined by the user. So the user does not define a custom preference or an interval. It will always call the agent at this given interval and ask the agent for the next steps or like the next intent to execute. Now let me just take this registry ID and go in and save it inside my env. Okay, now I have my registry ID set as well. Now let's, from a user's POV, let's deploy an automation account, or basically,
Expand the screen a bit, maximize the screen.
sure. I think it should be visible better now. Is this fine? Cool. So now I'll be going and deploying the account from the user's POV as well. We have abstracted it into a single script, but when you actually give it out to users, it would be packaged in a UI, and the user would be seeing each and everything. If I were to go back and show the deploy automation account script as well, the user comes in here, and the user again uses the SDK to deploy all of the sub account, deploy the Brahma account, and also subscribe to the given executor with all the policies that the user wants. Now, if we look at the policies here, yeah. So the user here also constructs his version of policy. When the executor comes in, the executor only tells the user that I'll be needing permissions on these set of tokens and these set of addresses. But the user finally decides that on these set of tokens and these addresses, what are the exact and the concrete policies that the user wants to give. So it is customized according to each user. Basically, user A can say, "Oh, I want to only give access to 10 USDC per hour. User B says I want to give access to 100 USDC or basically 200 USDC, depending on what kind of intent or the task it is asking the agent to do. Now, let's just go ahead and deploy an account from our user as well. Basically, in background, it will deploy a Brahma account and then a sub account, give access to the executor on that sub account, set up policies, and do everything. Just pre-computed the address of the deploying account. It is just polling and waiting for the account to be deployed. So ideally, my account Brahma account is ready, and along with the sub account. Let's just go and take a look at this transaction as well. You can see two accounts are created here. One is a multisig, which is the main Brahma account, which the owner has full control over, and second is the sub account, which the executor just got access over. Now, the script also transferred one USDC into the sub account so that executor can use it along with the given policies. Now, the automation is set. Now the agent is set up. The environment is also set up wherein the account is ready. The funds are already in the account. Now I'll just start listening for task, and basically whenever the task comes in, I'll just build the call data and start executing this automation. And this is my agent workflow file. Herein I poll tasks every few minutes or second, and the backend already populates the tasks according to the given user preferences. So if you have around 100 users and each of the user is expecting their task to be executed at a different interval, you don't have to worry about managing all of that. You just listen to the global task queue, which is assigned to you, and the console SDK already populates all of those tasks according to the user preferences. So you just focus on executing the final intent. Now, if I walk you through my workflow file, basically it is just listening to tasks, and for each user, I just verify a couple of params, and then I just do a simple send call to transfer the amount of USDC which the user asks for in every iteration or now this is a very simple demo showing how you can utilize like core actions, but this can be morphed into a fully autonomous agent which can basically do more complex stuff, use a lot of intelligence, and then take decisions on behalf of user. And yes, once I build my call data, I just spark it up. I just sign it from my executor's key, basically attesting that I'm the one building this call data and not some random user. And in the end, I just send it over to the console network, and the console network again validates it with the policy that whatever you have built is actually in scope with the user's policy, and then it is sent over for relaying. And even relaying is handled by us. Literally, the only thing that your agent has to do is give the intelligence, build the call data, and rest end-to-end abstraction is done by us. So this cuts off more than 80 to 90% of the tasks that on-chain agents have to do right now, and lets you focus on the core things and improving your agent logic instead of running through different kinds of infra setup and debugging those. Now let's just start. I'll just start my agent, and basically we'll see how the agent just loops over the task queue, listens to the user request, and executes the intents one by one. So there is again a simple command to set up and run your agent. I'll just do run agent workflow. Now, ideally my agent should start polling for the request. So it already got a request for the for the user which I had subscribed for, and right now it just sent the intent. It is waiting for it to be validated and sent across the network. I see my transaction has gone through. It again went into polling, and after 60 seconds, which was my defined interval as a user, it will pick up the job again, and it will again build the call data and send over. Let's go and check this executed transaction as well. So yeah, 0.2 USDC got transferred to the address that I had set as a user, and everything got executed within a few seconds. Now you can of course go inside the script, play with things, and basically change stuff to see how params affect each other. For example, if I go in here, I'll just change the transfer amount to basically transfer like 0.3 USDC. Yeah. So I'll just change it to transfer 0.3 USDC, which is still under the limits that the user had opted for. So if I just go to my deploy automation account script, you can see like as a user, I have set a limit of 2 USDC to be sent every iteration. So if I send anything beyond 2 USDC in my call data, it will be violating the policy and will be blocked. So basically, this could be like, oh, if you could build something like a smart monitoring agent, which basically takes a look at your balance and only refills the amount which is necessary and not like a fixed amount. So you could change params and make better decisions on the way before executing. So I just change the params and I'll just rerun the script again. It starts polling for the tasks, got the task and it executed again. Now, if I take this output transaction high, just wait for it to get indexed. And till then, let's walk a bit more over the console kit itself. Now, the console kit, alongside running these agent autonomously, it also gives some of the core features that we offer inside Brahma account, and they are the primitive DeFi actions such as swapping, lending, LPing, bridging, sending tokens across, and these are internally routed through through a lot of providers, and we have coverage of almost all of the chains that we are deployed on and new ones which are coming. So you can directly use something like a swap action inside your agent via our console SDK, and that would instantly give you access to swap on any of the supported networks that we are on. So that again will cut down the task for you to go and search for new swap providers or having to natively integrate with like a swap provider. So these kind of tools are already present inside the SDK, and inside we already leverage these to run our agents. Yeah. So the transaction got confirmed. Again, whatever param I changed, the same amount got transferred and everything went end to end smoothly. So now we saw how with like one simple script, you as an agent builder can basically offload everything related to execution and management and just focus more on building the core automation. Bring in your AI agent, bring in your LLMs, bring in your smart models or like more complicated or you can do more complicated stuff within your automation and everything is abstracted. And
So,
yeah,
like, I would like to touch base on these 2 points, right? Like, at the core, ConsoleKit basically gives you the developers manage like users funds in a non-custodial manner with the agents you build, right? And your agents are not limited in in terms of the on-chain interactions they can do, but also they can actually have access to a lot more users capital directly from the user account itself in the non-custodial manner. Now, this way, I think the benefit is both on your front, on the developers front as well, because you can easily serve your automation to a large set of users while just having to write the code only once, right? You don't need to maintain different set of preferences for each one of them, rather have like one workflow which manages across.
and yes, this obviously comes in with support for multiple networks, so you don't have to shift your system to work on chain A and then write it again or set up the infra to again work on chain B. One single script, access to all chains with the infra inbuilt.
Yes, and also someone asked if there are missing protocols in the console kit. If not integrated, can can they add it? They can add it, and we are open to PRs, right? So the repo is public as well. Once we review them, they can be merged as well. And also we have like a solver core action which is integrated, which supports like a lot more protocols that are not present, right? So you can actually do deposits on Aave, Pendle, a lot of other existing protocols directly from the solver action. It is quite generic and it is supported using uh, ENSO and GlueX protocols.
Yes. So that gives you access to almost all of the protocols. By default, the ones which are natively integrated inside of Brahma accounts, and then also infinite number of integrations which come in with the solver layer, which we added. So you do have access to most of the protocols out there, but if there is not a protocol which is already supported on the solver layer or natively integrated by us, the console kit is always open for new requests and for you to add new tools. And we always appreciate people adding and contributing to it. So another quick thing which I would like to add on is, since we are talking about these protocol integrations and all of these abstracted integrations, we also have another kind of example which basically demonstrate how this console kit can be used alongside these AI frameworks such as LangChain, OpenAI, and all of these frameworks. They are actions are natively supported as tools as well. So in case if you want to swap, you don't have to add any extra layer. You can just import console SDK, send it to the wrap it up in a tool and send add it in the framework itself. Now this again gives you this same level of abstraction, not having to care about where the user's account is, where the keys are, where the funds are. They are already in place, everything guarded, and you can just integrate your existing AI agent or like the existing agent workflow inside of an LLM or any open framework itself. So for example, let's say we have this sender tool inside of my OpenAI agent, which basically leverages the OpenAI SDK to give access to actionable send tool. So you can just check out the of OpenAI add
Yeah,
OpenAI branch.
this example we use our current ConsoleKit actions and we spec them out in the OpenAI format, right? So you can use them natively with any of the agents that are built using OpenAI. Similarly, we have a similar example with LangChain as well. So any of the LangChain kit fans out there, you can definitely use it.
So I'll just basically again abstracts the whole interfacing layer and gives access to the users to have a more chat-based flow to interact with your agent. And it just it the example has the core console get actions already pre-built, and you can always extend it to do something different and even interact with your agent as well. So basically, this example just builds a simple send call data and sends it back to the user to execute as well. So now this can be replaced by your own agent, and then the user is interfacing or like talking to your agent through a chat-based interface instead of having to go and like press buttons and do stuff. So yeah, this is what ConsoleKit offers all in all, and very excited to see what you all are building with ConsoleKit, and hope to see some cool ideas popping out of this. Yeah, and a more detailed way on how to use the ConsoleKit and how to set up the scaffold agent repo is already on our Notion page, which you through and see how to set it up, what kind of things you can build with ConsoleKit. We have also listed out some of the examples, maybe a auto rebalancing agent between Aave and intelligent DC or a swapping tool. So check out all of these examples, and basically this should
Yeah,
help to get
these are like
started with.
few ideas that we think that would make sense, right? So you guys can like actually go over them, or if you have any questions on one of these examples or how to use ConsoleKit for them, like you can always ask us.
Cool. Thank you all for joining in.